A point has no dimension. It is represented by a dot. A line has one dimension. It is represented by a line with two arrowheads, but it extends without end, no matter where the arrows are. A plane is a two-dimensional figure. It is represented by a shape that looks like a floor or a wall, and it extends without no end, just like a line. Distance is the space between point A and point B on a line. The real number that corresponds to a point is the coordinate of the point. The midpoint of a segment is the point that divides the segment into two congruent segments. A segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. The red dot shown is the midpoint of the line. An angle consists of two different rays with the same endpoint. The rays are the sides of the angle. The endpoint is the vertex of the angle. There are three different types of angles: acute, obtuse, right. Adjacent angles are two angles that share a common vertex and side but have no common interior points. Two adjacent angles are a linear pair. If two lines intersect to form a right angle, then they are perpendicular lines. A figure that lies in a plane is called a plane figure. A polygon is a closed plane figure with the following properties. It is formed by three or more sides. Each side intersects exactly two sides, one at each endpoint. Each endpoint of a side is a vertex of the polygon. A polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. A polygon that is not convex is concave. Circumference is the distance around a circle. Area is the amount of surface covered by a figure. A proof is a logical statement. A proof is a logical argument that shows a statement is true. There are several formats for proof. A two-column proof has numbered statements in corresponding regions that show an argument in logical order. A theorem is a statement that can be proven. Once you have proven a theorem, you can use the theorem as a reason in other proofs. Parallel lines do not intersect and are coplanar. Two lines are skew lines. Diameter is the length across the center of the circle. Radius is half the diameter. Parallel planes are two planes that do not intersect. A transversal is a line that intersects two or more coplanar lines at different points. Corresponding angles have corresponding positions. Alternate interior angles lie between the two lines and on opposite sides of the transversal. Alternate exterior lines lie outside the two lines and on opposite sides of the transversal. Consecutive interior angles lie between the two lines on the same side of the transversal. The slope of a non-vertical line is the ratio of vertical change, rise, to horizontal change, run, between any 2 points on the line. Rise is on the y-axis and goes up. Run is on the x-axis and goes on the x-axis. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. X-intercept is the point on the x-axis where the point hits the line. Y-intercept is the point on the y-axis where the point hits the line. A triangle is a polygon with three sides. There are three different types of triangles: scalene, isosceles, equilateral, and acute triangles. Acute triangles, which has three acute angles. Right triangle, which has one right angle. Obtuse triangle, which has one obtuse angle. Equiangular triangle, three congruent angles. Scalene triangles have no congruent sides. Isosceles triangles have at least two congruent sides. Equilateral triangle has all three congruent sides. The original angles are the interior angles, the angles inside the triangles. The angles that form linear pairs with the interior angles
are exterior angles.
In two congruent figures, all the parts in one figure are congruent to the corresponding parts of the other figure. Side, side, side. Congruence postulate proves a triangle is congruent to another triangle if all the sides are congruent. SAS is proving that two triangles are congruent by two sides and one angle being congruent. Hypotenuse-length congruence theorem proves that two triangles are congruent if a leg and the hypotenuse of the triangles are congruent. Angle side angle Congruence theorem proves that two triangles are congruent by having two angles in one side congruent. When an isosceles triangle has exactly two congruent sides, the two sides are the legs. The angle formed by the legs are the vertex angle. The third side is the base of the triangle. The two angles adjacent to the base are called base angles. A transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. The new figure is called the image. A translation moves every point the same distance in the same direction. A reflection uses a line of reflection to create a mirror image of the original figure. A rotation turns a figure around a fixed point called the center of rotation.
Triangle ABC, and we have these black lines here. These ones connecting in the middle. These are perpendicular bisectors. They bisect these lines and they're perpendicular to them. And where they meet here is the point of concurrency. And then these red lines are the distance from the point of concurrency to each individual vertice of the triangle. And this line from the top starts at A, goes down to BC, is a perpendicular bisector of BC with A on it, making Y equals 7, because both of these lines here, AB and AC, are the same distance from BC because A perpendicularly bisects the two, and it also makes a triangle, and so Y equals 7. And then all lines from the point of concurrency are the same length, so X equals 5, because this line is 5, so therefore X would equal 5. Okay, so we have these three red lines here, and they all are coming from one vertice and bisecting the line that they go across to, and not perpendicularly bisecting, just bisecting, which means that they are medians of this triangle. And since they are medians, we can solve for y, z, and x here, because the point here after the centroid is a third of this entire line, or half of this long part here before the centroid. So with that, we would get a half. X is a half of 6, which is obviously 3, so x equals 3. And y would be a half of 8, which is obviously 4. And then z, or a half of z, would be 7, so pretty much z is double of 7. So a half of z equals 7, then z would equal 14. Alright, so here we have these two triangles with congruent sides here and here, UA and OB, and AH and BW, but angle A and angle B are not congruent. This one's 90 and this one's 65. So, since angle A is larger than angle B, then the line UH is larger than OW, because if AU, these lines and all that are the same length, this one's at more of an angle, and through the hinge theorem, this line is going to be longer than this line. And also, these lines are going to, these lines are going to have to be over 3 but less than 11, because the sum of two sides of a triangle have to be over the other side. So if it was 3, they would be equal, and it couldn't do that. And if it was 11, they'd be equal if you added them a certain way, and it couldn't be like that either. It has to be over no matter what. And the same, even though this side is smaller than this side, the same rules will still apply because they have the same side lengths. Okay, so we have three triangles again, ABC and DEF, and we know all the sides here on ABC. It's 15, 15, and 3, but on D, there's two exponents. There's x and x on DE and DF, so we don't know those. We can, however, find those through proportions if we can prove that ABC is congruent to DEF. And we can do that because we know this angle, angle A, is congruent to angle D because there's a little line here, and angle E is congruent to angle B because of the two little lines. And that proves that these two triangles are congruent, because if angle D and angle A are congruent, angle B and angle E are congruent, then angle F and angle C have to be congruent, because it's the leftover of 180 degrees, which is the sum of all interior angles on every triangle ever. And if all angles are congruent, then they are going to force all the sides to be proportionate because they have to make the same angles and everything. So now that we have proven that ABC is similar to DEF through the angle-angle postulate, we now can find X through proportions like we did earlier, 15 over 3, X over 1, and just cross multiply, 3x equals 15, and then we come out with x equals 5, and that's that. Okay, so here we have another two triangles, and we know that angle B here is congruent to angle E, but that's all we really know, and then we know these side lengths here. But we can prove that these triangles are congruent because if we set up a proportion like this, we see that the sides are proportionate because both of these simplify to 6 over 1. So these sides are proportionate, and that proves that the two triangles are similar because the side AB, angle B, side BC theorem, which states that if two sides and their enclosed angle are similar, proportionate, etc., then the triangles are similar, because if these are the proportionate lengths and it's the same angle size, they're going to end up making the same another proportionate side here in the end. And with that, we could solve for x by setting up another proportion here, and we just cross multiply, and we get x equals 7. Alright, so here we have another triangle, and we have these unknown lengths, x here after the 16, y and z, and we can find these by setting up a set of proportions, because when you take an altitude from the hypotenuse of a right triangle, it divides it into two proportionate right triangles, which are proportionate to both each other and the larger right triangle that they make up. So we can solve for x by setting up a simple proportion, because these two are similar triangles, and we just cross multiply and solve and get x equals 9. And with that, we can set up a proportion with this small triangle here with the 9, the 12, and the y, with the larger triangle to get this proportion, and we cross multiply, square root, and we get y equals 15, and then from there it's another simple proportion, and we get z equals 20. Alright, so here we have another triangle. We know the angle measures and one side length, but we don't know this x or this y, but we can find them through the tangent, sine, and cosine ratios. So we can find x by using the tangent of 54, which is across 42, over adjacent, which is x. So we just, multiply both sides by x, and that comes out at about 30.51. And then we can find y with the cosine of 36, which is the adjacent, which is 42, over the hypotenuse, which is y. And then we just do the same thing, and that comes out at about 51.91. Alright, so here we have a quadrilateral, and we know that this quadrilateral is a parallelogram because it has two pairs of congruent sides that are not congruent to each other, like ZV is congruent to YX, but not YZ, and the other way around and everything. And if angle V is 110 degrees, the angle Y is going to be 110 degrees, because all opposite angles in a parallelogram are congruent. And then angle X is going to be 70 degrees because consecutive angles in a parallelogram are supplementary, and then the same thing as angle Y. Angle Z is going to be 70 degrees as well as X. Alright, here we have another quadrilateral, and we know that this quadrilateral is a kite because it has two sets of congruent sides that are not congruent to their opposites. So LT is congruent to RT, but is not congruent to UR, and there's two sets of those, and since this is a kite, we know that all angles stemming from point A, RAT, UAR, LAU, and LAT are all going to be right angles because the diagonals in a kite are perpendicular to each other. Okay, so here we have another quadrilateral, and it is a square, which we know because it has these four right angles, and it has these two sides that are congruent. If these two sides are congruent and all four of these angles are right angles, that would mean that the other two sides would be congruent because they are all the same angle and it encloses itself, so they would be the same length, which means that x would equal 7. Alright, so here we have yet another quadrilateral, and we know that this one is a trapezoid because it has, ignoring this middle one here, it has two parallel lines. The two bases are parallel, but the two sides are not. And this is the line across the midpoint of the two lines, of the two sides. And we can solve for x, which we'd set up like this, because it is half of the sum of the two bases, the middle section here. So it's going to be half of 18, which is 9.
A central angle of a circle is an angle whose vertex is the center of the circle. In the diagram, angle ABC is the central angle of circle C. If the measure of angle ABC is less than 180 degrees, then the points on circle C that lie on the interior of angle ABC form a minor arc with endpoints A and B. The points on circle C that do not lie on the minor arc AB form a major arc with the endpoints A and B. A semicircle is an arc with endpoints that are the endpoints of a diameter. For a square, the area is one side squared. For a rectangle, the area is the base times the height. For a parallelogram, it is as well base times height. For a triangle, the area is 1/2 base times height. The area of a trapezoid is 1/2 the height times base 1 plus base 2. The area of a rhombus is 1/2 diameter 1 times diameter 2. Area for a kite is 1/2 d1 times d2. The circumference of a circle is pi times diameter, or 2 pi radius. The area of a circle is pi radius squared. The ratio of the area of a sector of a circle to the area of the whole circle, pi r squared, is equal to the ratio of the measure of the intercepted arc to 360 degrees. The diagram shows a regular polygon inscribed in a circle. The center of the polygon and the radius of the polygon are the center and the radius of its circumscribed circle. The distance from the center to any side of the polygon is called the apothem of the polygon. The apothem is the height to the base of an isosceles triangle that has two radii as legs. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of the polygon. A prism is a polyhedron with two congruent faces called bases that lie in parallel planes. The other faces, called lateral faces, are parallelograms formed by connecting the corresponding vertices of the bases. The segments connecting these vertices are lateral edges. Prisms are classified by the shapes of their bases. The surface area of a polyhedron is the sum of the areas of its faces. The lateral area of the polyhedron is the sum of the areas of its lateral faces. The following are formulas for surface areas of different 3D figures. The total surface area of a triangular prism is 2 times the base plus the perimeter of the base times the height. The surface area for a cylinder is 2 times the base plus the circumference times the height. The surface area for a pyramid is base plus 1/2 the perimeter times the height, times the lateral height. The surface area for a cone is the area of the base plus 1/2 the circumference times lateral height. The following are different formulas for the volume of certain 3D figures. The volume of a cube is one side cubed. The volume for a rectangular prism is the base times the height, the area of the base times the height. The volume for a cylinder is the area of the base times the height, or pi r squared times height. The volume for a pyramid is 1/3 area of the base times the height. The volume for a cone is 1/3 pi r squared times the height. The surface area of a sphere is 4 pi r squared. The volume for a sphere is 4 over 3 pi r cubed.